Bismillahirrahmanirrahim. Assalamu alaikum, student.
Walaikum salam.
Alaikum salam.
Okay, so today our target is to solve the problems, and last time we have solved some problems like this one and this one and this one and this. You remember this one, okay? And this problem I think we have solved or not. I don't remember this one. I think solved. So what is the position of the particle when it achieves its maximum speed? So maximum speed you will be obtained when acceleration is 0. So you will find the time. Okay. So you can solve this one. And also I solve this one. And this one I have given you for an assignment. Maybe you have solved. These are the simple problems. And this is also a bullet shot straight up returns to its starting point in 10 seconds. What is the initial speed of the bullet? So you know that already we have studied some formulas to solve the problems of this free fall motion. So see this problem. In this problem, this is the bullet. This is going up in 10 seconds, and you want to find VI. And you know that at maximum height, its final velocity will be 0. So it takes a time of 10 seconds. So you remember that we find the formula upward time is what? VI over G, I think. So from here you can find the VI T plus T into G. So T is what? 10 seconds and G is 9.8. So in this way you can find the initial velocity of the particle. So this is 98 meters per second. Understand this one? So this is for up, and for down you remember that the same formula, okay? And for up and down the formula will become 2VI over G. So you should remember this one. Okay, after this, okay, see this problem. This is a little tricky problem. So here you can see if we have a velocity time graph. This is the velocity time graph. The question is, what is the acceleration at 1 second? So here we have 2 seconds. At this position, we have 2 seconds. Okay. So 1 second surely will be here. We don't know where is here 1 second. So we know that the velocity time graph, the velocity is increasing with respect to time and constantly increasing. So you will find the slope. So the slope will be what? Slope will be delta V over delta T. And delta V is what? V2 minus V1 over T2 minus T1. V2 is what? This is your V2. And V2 is 2 minus 0 because this is 0 in this triangle. So 2 minus 0 over 2 minus 1. Okay. So what is the answer? Oh, sorry, this is not 2, this is 20. Y-axis is what? 20. This is 20. And this is equal to 20 over 2, and this is equal to 10 meter per second square. So acceleration will be constant at this line. Either you will find here or here or here or here. It will be 10 meter per second square. This is the first part. Okay. What is the acceleration at 3 seconds? So 3 seconds is here. This is 3 seconds. So at 3 seconds, the line is parallel to time axis. So velocity is constant. Velocity is constant. Acceleration will be 0.
0.
Okay, understand? So what is the average acceleration from 0 to 5 seconds? So 0 to 5 seconds, you will you can find the average acceleration. So from here to here. So here is 5 seconds. here is 5 seconds, and here is 0 second. Okay. So what you will find for this part, so average acceleration will be what? V2 minus V1 over T2 minus T1. Okay. And this is equal to, yes, how we can find? This maximum our V2 minus V1 divided by T2 minus T1.
10 minus 10.
10 minus, not 10,
0
10
0
minus 0. Yes. Because here the acceleration at this point is what? What is the acceleration at this point?
10.
It is
No,
10.
no acceleration.
It is 10. Here is 10. Here is also 10. Okay. So the final acceleration is what? So this is the, here is 10 and the initial will be what? 0. So 10 divided by how much? The time? 5 seconds. So you will find here 2 meter per second square. What is the average acceleration from 0 to 8 seconds? Yes. 0 to 8 seconds will be what? So 8 seconds is here.
V2 minus V1 on T2 minus T1.
Yes.
V2 is negative 20 and
Yes.
V1 is 0.
0. Yes. So you can find this one also. Okay. And this is what? What is the displacement? So the displacement is this one. You will find the area under this triangle. You will find the area under this triangle, this rectangle. Okay. So rectangle is what? Or the square is like this one. This is rectangle actually. So you will find the area of this, and area of this, and area of this. So the total area you will add, and then this area you will subtract, because we want to find the displacement. We are not finding the distance. If we want to find the distance, then all areas we will add. So what is the area of this one? Yes. 1 over 2 into 2 into
20,
20.
doctor.
20. So answer will be 20.
20.
For this triangle, the area is 20. For this rectangle, the area is what?
40. 40.
2 into 20. 2 into 20 is 40. You know that area of triangle is 1 over 2 base multiplied by height. 1 over 2 base multiplied by height. Okay. So base is this one and height is this one. So that's why I write this formula. 1 over 2 base into height. And for this one, the length and the breadth. So length is 2 to 4 is 2. And from here to here, it is 20. So length into breadth is 40. Okay. After this, find this area. So this is the same value which we have found early, because this triangle and this triangle is same. So the answer will be 20, 40, 20. And now find this area. This area is how much? 20. This is also 20. Okay. But this is negative side. So this will cancel with this one, and 40 plus 20 will be what? 60 meters. So please remember, if you want to find the displacement, you have to subtract this area from the whole area of this one. Okay. But if you want to find the distance, what you will do? You will add all the areas. So here we have a 60, otherwise the distance will be 80. Okay. I think you understand this one. Okay, so last time I discussed this problem, you remember? Yes, you remember or not?
Oh, we didn't take this question. We take only the first 4 questions.
Okay. We didn't solve this one? No.
No.
Okay. Okay. See this one. A rocket is fired vertically upward with an initial velocity of 80 meter per second from the ground. This problem is a little tedious problem. So here its initial velocity is given and this is 80 meter per second. Okay. From the ground, this is the ground level. It accelerates upward at 4 meter per second square. So its acceleration is not g, its acceleration is given this value until it reaches an altitude of 1000 meter. So this is 1000 meter. This height is 1000 meter. And this is the point, a point where it reaches, and the height is from the ground to a point is 1000 meter. Now what happened? At that point mean after reaching 1000, its engine fail. So its engine fail. When its engine will fail and the rocket moves under the influence of Earth's gravity only with an acceleration of minus 9.8 meter per second square. So it's this acceleration finish, but the acceleration due to gravity is now acting on it. So when the acceleration due to gravity is acting, then it will little move up. Okay, due to this thrust, you can understand. So it covers some distance h up to this level, and this is its maximum level. This is its maximum level. It can go up. So what we have to do? We have to find the final velocity at this point first. So to find the final velocity at this point, we will apply the formula vf square minus vi square is equal to 2g. I am writing here g and h. H are this distance, I am saying y. Okay, y. So vf square minus vi square 80 square is equal to 2 into g. Here g is actually a into y. Y is 1000. So vf square is equal to 80 square plus this is a is here 4. I am writing here 4. So answer will be 8000. 1000 multiplied by 4 multiplied by 2, 8000. So when you solve this equation vf, you will solve it 80 square in the calculator and 8000 and under root, its answer will be 120 meter per second. Okay. Now its velocity at this point is 120 meter per second. When its engine fails, it moves a little up, more up. Okay. When it reaches at the maximum height, its final velocity will be 0, and now this will become the initial velocity. So we want to find this distance. To find this distance, apply the same equation. So same equation is this one, 0 square minus 120 square vf square minus vi square is equal to 2 into, now from A point to B point, the rocket is moving under gravity. So the acceleration is minus 9.8 and multiply by h. We want to find h. So in this way, if you solve this equation, if you saw, I'm making here a line. So if you solve this equation, the answer will be 735. You can check this one. Okay. So the total height will be 1000 plus 735. The total will be 1735 meter. This is the answer. So in this question, what is the logic? Logic is this one. The rocket is moving with an initial velocity, speed 80 meter. At this point, after reaching 1000, its engine fail. When engine fail, the acceleration due to gravity acts, although it is acting here, but we are ignoring that one and we are only taking the acceleration of that rocket. Okay. So you will take only minus 9.8 here. Okay, so then solve it. Okay, now understand this one. Okay, after this,
Doctor,
yes,
you said you will give us, you will send us a sheet of the questions.
this sheet I will send you first, and then I will send you more sheet during this off days. Okay,
How many questions is it, teacher? Doctor, sorry.
where?
How many questions is the paper or the file?
Brother, still I don't know about this one, because they will take one midterm or two midterm. This is a question. If they are taking one midterm, maybe they will give you more question. If they are taking two midterms, then they will give you 15 questions. Okay.
Okay, thank you.
Yeah. So it depends on the number of midterms, 2 or 1. So here you can see, if you toss a ball upward with an initial speed vi. So toss a ball with an initial speed vi. We don't know this speed, and reaches a maximum height h. This is maximum height. So remember, when in the question it is maximum height, then final velocity will be 0. By what factor must you increase the initial speed of the ball for it to reach a maximum height 3h? So he is asking, if you want to throw the ball up with 3h, if this is h, now this is 3h, what will be the vi? So this we have to find. So here they don't give any kind of data. You just solve it in general form. So the same formula, vf square minus vi square is equal to 2gh. Okay. So vf is 0, minus vi square is equal to 2 into minus g upward and into h. So vi square is equal to 2gh under root. This is one formula. And from here, again, the body is at the highest position. The final velocity is 0, and minus vi square is equal to 2 into g into h. So here h is 3h. Okay. So here vi is equal to 6gh under root. This is vi dash. This is vi. So he is asking, by what factor you must increase the initial speed. So we have to find the factor. So vi dash is equal to 3 into 2gh under root. Okay. So vi dash is equal to 3 under root into 2gh under root separate. So 3 under root, and this is what? This is actually vi. So this is vi. So vi dash is equal to 3 under root of vi. So how much factor we have to increase the speed? 3 under root. So answer is actually 3 under root. Okay.
Okay.
So after this, these are some, okay, one more thing which I want to tell you. In chapter number 2 from the book, I already sent you the book. Okay. So in the book, you have seen some concept quizzes. In the book, chapter number 2 or in chapter number 1, which is related with your articles. Related with your article, you must solve these quiz. And in the exercise, when you see the exercise and when the exercise end, then they have given the answer of these quizzes. Okay. So prepare these one quickly. This is very important. Sometimes they have given two questions from these quizzes. Okay. The question is, can you have zero velocity and non-zero average acceleration? Can you have zero velocity and non-zero average acceleration?
Yeah.
Yeah.
Yes.
Yes.
So
Yes. Why? Yes.
If you moved in a certain speed, then suddenly stop, you will have zero acceleration at that moment, zero velocity at that moment, but you will have an average acceleration.
Okay. But you can understand that acceleration is what?
Not zero.
No,
Changing.
acceleration equation is what?
Changing velocity.
Change in
Delta
velocity,
V.
v2 minus v1 over t. I'm writing here delta t. Okay. So if non-zero average acceleration, this is non-zero, and can you have zero velocity? So
Yeah.
zero velocity exists, but change in velocity is not zero. He is not saying the change in velocity is zero. He is saying the zero velocity. So zero velocity can exist at any point, and non-zero acceleration exists. Understand this one, because you must understand that acceleration is not velocity over time. Okay, acceleration is not velocity over time. Acceleration is delta v over delta t, or v2 minus v1 over t2 minus t1. It means to find acceleration, you need two velocities, the difference of two velocities. So if one velocity is zero, then non-zero average acceleration exists. Yes. So the next question is what? Can you have zero acceleration and non-zero velocity?
Yes, you can.
Yes.
Yes.
If
But
you
the
put here
velocity-
zero, then v2 minus v1 over delta t. Okay. So you can solve it, and v2 is equal to v1. Maybe it is zero, maybe it is not zero. Okay. So can you have zero displacement and non-zero average speed? Zero displacement. Yes. Zero displacement exists when?
when you
When-
come and when you go and
Yes,
come back.
when it comes back to its initial position. So its average velocity will be zero. Average velocity can be zero because it's d minus d, like this one. Okay. But average speed will be zero. So here he is saying non-zero average speed.
No, you
I
can't
don't think
have,
you
zero
can.
displacement.
Yes.
You can't.
Yes, can't. Can you have zero displacement and non-zero average velocity? Zero displacement and non-zero average velocity. Yeah, think about this one. I have taken this question from some other site.
No,
Yes.
can't.
Huh?
Can't.
Zero displacement. Okay. V is equal to d over t. So if we put here zero, and V will be non-zero. V will be non-zero.
No,
Can
it
it?
will be zero.
No.
You can't.
Is it possible that V is some value? V has some value. Non-zero means some value, and this is zero.
No, we can't.
No, impossible.
I think not possible. Okay. Under what condition is average velocity equal to instantaneous velocity? Average velocity is equal to instantaneous velocity.
It's constant.
Yes, it is constant. Constant velocity when the body is moving with constant velocity. Okay. This question is important. Under what condition? Under constant acceleration, the average velocity of a particle is under constant acceleration. The average velocity of a particle is half the sum of its initial and final velocities. Mean what? The average velocity is Vi plus Vf over 2. This is, he is saying like this one. Is this still true if the acceleration is not constant? No,
No.
it is not true. It is only valid if it is moving with constant acceleration. Okay.
Doctor, can you go back?
The third one, what was the answer?
This one,
Yes.
can you have zero displacement? Okay, just zero displacement and non-zero average speed. Because displacement and average speed has no connection.
we said-
Displacement connection is with velocity. So we can say no.
Okay.
Okay. When you drop an object from a certain height, it takes time t to reach the ground with no air resistance. If you dropped it from 3 times that height, how long? Here you can see again, the term is using how long. How long, how far, and how fast. These 3 terms are frequently used in problems. How long mean time. How far mean distance or displacement. Okay. How fast mean speed or velocity. So this is the same problem which I have solved before, the 3 under root vi. If you solve this one with the same notations, you can solve it very easily. Okay. Check yourself. Okay. Magnitude. Yeah.
Can you solve the question 5 to 7?
5, 7 where?
The slide. Slide
Okay.
5 to 7.
Okay. Just wait. Just wait.
Okay.
Under what conditions does the magnitude of the average velocity equal to the average speed? Yes, magnitude of average velocity equals the average speed.
The position and the distance and displacement are equal.
Yes, but sometimes can be equal. Huh? Under what conditions? If the body is moving in this way, I think. In this way. If you want to find the average velocity or you want to find the average speed, it is the same, I think. It is moving in the same direction. When it is moving in opposite direction, then the average velocity will be different because the displacement will be negative. When the displacement is positive in this direction, then it is okay. Just 1 minute. Yes. यार इस वक्त हमारी क्लासेस तो होती हैं, आप ले लें चाबी, लेकिन ये है कि क्लासेस जो है ना वो हमने लेनी होती है, वो ऑनलाइन क्लास ले बस ठीक, आप ये ले लें या आइए sorry, actually the persons are doing work here in the labs. Okay, so you understand this one? Under what condition does the magnitude of the average velocity equal the average speed? Okay, so the average velocity and the average speed, it is it depends on what? It depends on what? It depends on the distance or the displacement. So the average speed is total distance over total time. And average velocity is what? The total displacement over total time. So the if the displacement is positive and negative, then average velocity magnitude, you will find it will be different than this one. But under what condition? He is asking under what condition? If it is moving in the same direction, because in the same right side direction, the distance or the displacement will be the same for average speed and for average velocity. So this is the condition. Okay. Okay, so which question?
5 to 7. Slide 5 to 7. Yes.
This one?
No. Slide 5. Yes, this.
Yes, this one is the position of a particle moving along the x-axis is given by x is equal to 6t square minus t cube. 1t cube mean 1. Okay. Where x is in meter and t is in second. What is the position of the particle when it achieves a maximum speed in the positive x direction? So we have to find the position, mean the distance of this 16 meter. Okay. So first, what you will do? The maximum speed exists when the acceleration is 0. Okay. So what we will do? We will find first the velocity dx over dt. It is 12t minus 3t square. Okay. Then find, this is your v. So you will find the dv over dt. So dv over dt will be what? 12 minus 6t. Okay. 12 minus 60. This is 12 and this is 3 to the 60. So this is your acceleration. So acceleration will be 0 at when the speed is maximum, and 12 minus 60. So t is what? Here it is 12 over 6 is equal to 2 seconds. So at 2 seconds, you will find the distance. So x is equal to 6 into 2 square minus 2 cube. So this is 4 and 24 minus, what is this? 2 2 is the 4, 4 2 is the 8, and this is 16 meter. This is the answer.
Doctor,
Yes.
why we said minus 3t to powered?
This one,
Yes.
we are taking the derivative of this one. Derivative.
Oh, okay. Yes.
6
Thank
2 is the 12t minus, here is 1.
One.
Okay. 3 1s
Yes.
the 1, 3 1s the 3 t square. Then again
Yes,
take
yes.
the derivative. 12 minus 3 2 is the 60. Okay.
Yes, clear. Thank you.
Okay. Then another question. Yeah, this one. So in this question, a car starts from rest. Yes. Vi is equal to 0.
0.
Accelerates at 4 meter per second square. For time is equal to 5 seconds. Then maintains the first, find the velocity. Okay. So you can find the velocity. Vf is equal to Vi plus At. So Vf is equal to 0 plus 4 into 5. And this is equal to 20 meter per second. Okay. So then maintains that velocity for 10 seconds. Okay. And then decelerate at a rate of 2 meter per second square for 4 seconds. So what you will do? You have to find 20 meter and maintain this one for 10 seconds. Okay. And then decelerate. So you need the velocity when it is decelerates. What is the final velocity of the car? So final velocity will be what? So apply the same formula. This one. So here Vi is what? This Vf will become Vi. No. Because it is like this one. This is 20 meter per second constant and then decelerate. Okay. And minus A. A is what? 2 into T
2.
is what?
4.
4. So 20 minus 8 is equal to 12 meter per second. So this is the answer. That's why. Okay. So similarly, you can solve this problem. This is easy problem. Okay. This is already I have. Okay. So after these problems, I just want to explain something more. More is this one. More is this one. Suppose. Now these are the tricks. Okay. If we have V is equal to -8 plus 4t, this equation, and we want to find the displacement at 4 seconds. Displacement for 4 seconds. So how you will find the displacement? Yes. This
Total displacement over total time.
at 4 seconds. So see
Oh.
this one. This equation is in this form. I can write this equation VF is equal to VI plus AT. Okay. You can compare this equation with this one. Here VI is what? -8. This one. And A is what? 4. A is what? 4. And T is T. Okay. So you can find the S or X is equal to what? VIT plus 1 over 2 AT square. What is the answer? VI is -8. T is 4 plus 1 over 2. A is 4. T square. 4 square. -32 plus 2 into 16 -32 plus 32. Answer is
0.
0. So 0 is what?
Displacement.
Displacement. So displacement can be 0. But distance
This is always positive.
distance is always positive and some value. Always positive and some value. Now you understand this one.
Yes, doctor.
Okay. Now
Doctor, I have
see.
a question.
Yes.
How did you know that T is equals 4?
It is
The
given.
time.
It is given. T is equal to
Great.
4 seconds. Find the displacement. I'm writing here. Find displacement for T is equal to 4 seconds.
Okay.
Okay. So if he is asking, now I'm giving you the tricks. If he is asking that find the distance. So equation is V is equal to -8 plus 4T. So if you want to find the distance, it is 0? No, it is not 0. It has some value. Okay, what we will do? That's why the graphical motion is important. So now you can see the importance of the graph, but here mostly the teachers don't focus on the graphs. Okay, if at T is equal to 0, T is equal to 0, what is the answer? V is equal to what? -8. Okay, so this your time axis is this the one, this is your V axis. So this is 0 and this is -8. Okay, so if T is equal to, suppose 2 seconds, what is the answer? V is equal to what? V is equal to 0.
0.
0. It means if I am saying that here is 2 seconds, then this line will be like this one. Okay. If I increase this time 4 seconds further, then it will go up. Okay. So when it is 4 seconds, T is equal to 4 seconds, 4 4s the 16, -8, answer is +8. Okay. The value is this one. So the graph line is this one. Now you can find the distance from this triangle, area under the graph. Now remember, area under the graph, under VT graph, will give you the distance if you add that one. So if I am taking this whole triangle, suppose this is the whole triangle and this is 4. So if you want, this is 4. Okay. So if you want to find the area under the triangle, how you can find? Yes, area will be 1/2 into base. Base is what? 4 into height. Height is what? Here to here is what is the distance?
16.
16. Okay. So answer is what?
32.
32 meter. So this area is distance. This area is distance. It is not displacement. But if you want to find the displacement, then it is this one. So here you can see from this equation, you find the distance and the displacement. Okay. So a lot of questions and problems exist, but okay, I will send you the problems and the questions of different kinds and you can solve and try to make a practice. Okay. So if you have any other question, you can ask. No, this chapter number 2 from my side is finished because I have discussed with you many things. You remember that I discussed this chapter number 2, the position, the distance, you have to control this one, the displacement, the speed, the velocity, and in velocity, average velocity and instantaneous velocity and constant velocity, you should know. And then acceleration, and similarly average acceleration and instantaneous acceleration and constant acceleration equations we have discussed, equations of motion for constant acceleration, and then we discuss the free fall, and then we discuss the graphical explanation. After graphically, then we solve the problems and discuss some questions. So I think now this chapter is complete. If you have any question, any problem, mail me by my official email, not with the Gmail. Okay. Gmail is I'm using just to send, using for a Google Drive. Okay. So this email you will use, the actual email. Okay. The university email. So then I will try to solve that problem. Okay. So I stop the lecture here, and I think next time we will start chapter number 3.
Thank you, Doctor.
Okay.
Thank you.
See you in the
Thank you, Doctor.
next lecture. Okay. Assalamu alaikum.